solving second-degree polynomials. By second degree, we mean that the highest power is a 2. It's also true that there are usually 2 solutions. Here's a second-degree polynomial. Watch out for this. If there's only an x squared term and there's no other terms with variables, then just get that by itself and take the square root. So I'm going to add 5 to both sides. I have 3x squared left and 21 on that side. These are gone. Divide by 3 on both sides to get x squared by itself. So x squared is 7. When we take the square root to get x squared by itself, remember this is plus or minus the square root of 7. And I can't simplify that. These are my 2 solutions, x is square root of 7 or negative square root of 7. This one's different. Now, in addition to x squared, we also have an x term. You cannot get x squared by itself and take the square root because you'll be stuck with an x on the other side of the equation. And you can't add or subtract these terms together because they're not like terms, so we need a new strategy. The new strategy is going to be using factoring. So let's review how to factor a trinomial like this. In another video, we talked about using the box method. There's other methods too, and they all come out with the same answer. As long as you know how to factor, it's fine. But I'm going to use the box method. So remember, I've got x squared in one box and 21 in another. And in the other 2 boxes, I need 2 x terms that add up to negative 10x. They're also made of the factors of 21. So for factors of 21, I've got 1 times 21, 3 times 7. The only way I'm going to get a pair to add up to negative 10 and multiply together to give me positive 21 is if they're both negative. So look at it this way. Which of these pairs adds up to negative 10? Clearly it's this one. So in these 2 boxes we put negative 3x and negative 7x. The order does not matter. Now factor up the columns and across the rows. So up here I factor out a common factor. The only common factor is x, and I pull out a positive x because the first term is positive, the one on top. Next, I have something negative because the top term is negative. The common factor they both have is 3. So that's what I factored out of that one. Now we factor across this way. Since x squared is positive, I'm pulling out a positive common factor, which is x. And now this way. Since negative 7x is negative, I'm pulling out a negative factor, and the common factor of negative 7x and 21 is 7. So now I have my 2 binomial factors, x minus 3 and x minus 7. And if you multiply those back together, you would get this trinomial. So these are the factors. So let's see how that helps us solve that equation. Well, now I'm going to use something new called the zero product property. Here's what the property states. If you have a number a, any number, times some other number, let's call it b, and the product of those 2 numbers is 0, we know for sure that either a could be 0 or b could be 0, and those are both solutions to that equation. Because if a is 0, it doesn't matter what b is. But if b is 0, it doesn't matter what a is. It would wipe it out, right? So we're going to use that property to solve this. Either this or this must be equal to 0. So solve both. Either x minus 3 equals 0 or x minus 7 equals 0. This one comes out to be x equals 3, and this one is x equals 7. These are both solutions to this problem. Let's try plugging those numbers back into the original polynomial to see if they work. If x was 3, I would get 3 squared minus 10 times 3 plus 21. Does that equal 0? Let's see. 9 minus 30 plus 21. That is negative 21. So that's 0. Okay, so 3 is definitely a solution. Let's try 7. 7 squared minus 10 times 7 plus 21. Okay, that's 49 minus 70 plus 21. Does that equal 0? Well, this is negative 21. So again, that's going to equal 0. And those are both solutions. Make sure that you circle or box in your solution. And make sure that you check your solutions to make sure that they work. You could have made an error and it would show up. If you plug it back in, it won't work. And that should tell you that you need to do some more work. Let's try another one. Now this one has an x squared and an x term, so I do have to use factoring. But I can't use the zero product property unless it's equal to 0. So before you start, you need to subtract 10 from both sides to get it equal to 0. So that turns into x squared minus 3x minus 10. I can't really combine those. They're not like terms, right? Now that it's equal to 0, we factor it. Remember how to do that. Okay, this time our product is negative 10, so keep that in mind. One of the factors has to be negative and the other has to be positive. Since the middle term is negative, that means the larger factor needs to be negative, so we do this. Now, which of those makes a sum that matches our middle term, that negative 3? It's this one, right? That makes negative 3. So those are the factors. Those are our x terms. So we put 2x and negative 5x, and then factor out common factors. Both of those, 2x and negative 10, have a 2 in common. And since the top term was positive, that's going to be positive 2. And then we go this way. So the common factor in the top row is x, and in the bottom row it's going to be negative 5. Our two factors are x plus 2, x minus 5. And that's still equal to 0. Now use the zero product property. So either x plus 2 equals 0 or x minus 5 equals 0. That means x has to be negative 2 or 5. These are both solutions to the problem. Let's check them. If x was negative 2 in the original problem, that would be negative 2 squared minus 3 times negative 2 should be equal to 10. Let's see if it really is. 4 plus 6. Yep, that's 10. Now let's plug in 5. 5 squared minus 3 times 5 equals 10. That's 25 minus 15. That's definitely 10. All right, so there's two kinds of problems you need to watch out for. If you see an x squared and an x, you need to use factoring. You need to set it equal to 0, okay? If it just has x squared and no other variables, then get the x squared by itself and take the square roots. And those are your new methods for solving second degree equations.